In this video, we are going to do a problem based on finding the different types of entropies and mutual information. Okay, but I want to tell to all of you that before doing this problem, I want you all to revise the previous portions. Okay, the different types of entropies, they are formulas. The formulas are very important. The formulas and the concept behind the formulas is very important, and also the relationship between entropies. Okay, and you have to remember all those equations if you want to do this problem. All right, this is a very big problem. It takes so much of time, and more time it takes to type in the equations around into the calculator. Okay, so that all you should learn how to do it, right? So here the question is, determine the different entropies and I of xy for the joint probability matrix JPM given below and verify their relationship. Okay, so this is the question. They have given you a joint probability matrix P of x comma y, and they're asking us to find the different types of entropies, that is h of x, h of y, h of x comma y, h of y by x, right? They ask us to find h of x, h of y, h of x comma y, h of x by y, comma h of y by x, and then they ask us to find the mutual information I of x comma y. These are the different entropies they're asking us to find. Okay, and also verify their relationships, right? So how do we find these entropies? Using those basic formulas, right? So whichever entropy you're going to find, let it be any entropy, whichever entropy you're going to find, first you need to find its corresponding probability matrix. For example, if you are going to find h of x, then you need to find what is p of x. Okay, and if you're going to find h of y, then you need to find p of y. If you're going to find h of xy, then you need to find p of xy. P of xy is already given in the question, right? So this you can directly find, right? And then you have to find p of x by y, then you have to find p of y by x. Then only you can apply those values to find these entropies. And then finally you can use any one of these basic equations to find the value of mutual information. Okay, so here in this video I'm going to tell you the process of the steps of how to find all these entropies. Okay, but I'm not going to explain to you the reason behind the steps, because the reason behind this process is already explained in the previous video. So that is what I actually need you to understand. Okay, I'm going to tell you how we are going to find this problem, but you need to understand why I'm using this method to find this problem. It's all based on the equations. Everything is based on the equations. Okay, so let's begin. So first I'm going to find this. I'm going to find h of x. Okay, so to find h of x, I need to find p of x. Before finding h of x, I need to find p of x. Then only I can apply those values to find h of x. So to find p of x, how do I find p of x? That is, you need to understand this. Okay, how to find p of x is that if you add all the elements of the first row, if you add all the elements of the first row, you will get p of x1. If you add all the elements of the second row, you will get p of x2. If you add all the elements of the third row, you will get p of x3. If you add all the elements of the fourth row, you will get p of x4. If you add all the elements of the fifth row, you will get p of x5, right? So therefore there are 5 transmitter symbols, right? And how to get is simply adding all the rows. Like I said before, the reason of this is already explained in the previous videos, and that is what you need to understand. Why, how I got this. Okay, it's simply because we already learned the reason why it's like that. If you add all row wise, you will get p of x1, p of x2, p of x3, p of x4, p of x5. Okay, so that means p of x is equal to it's a set of these values, right? So p of x is equal to, what is p of x1? 0.2 plus 0 plus 0.2 plus 0, which is 0.4. This is p of x1. Okay, next is p of x2. What is the value of p of x2? 0.1 plus 0.01 plus 0.01 plus 0.01, which is 0.13. Okay, now next I'm going to find the value of p of x3. So what is the value of p of x3? 0 plus 0.02 plus 0.02 plus 0, which is 0.04. Okay, comma. Next I'm going to find the value of P of x4. How do I find the value of P of x4? 0.04 plus 0.04 plus 0.01 plus 0.06. How much is that? 4 plus 4, 8, 8 plus 1, 9, 9 plus 6, 15. So it is 0.15, comma. And to find the value of P of xy, it is 0 plus 0.06 plus 0.02 plus 0.2, which is 0.28, right? 0.28. This is how we find the value of P of x. Once when I found the value of P of x, now I can find the value of h of x. So what is the equation of h of x? H of x is equal to sigma k is equal to 1 to m P of xk log of 1 by P of xk. This is the equation. Okay, this is the equation. So which means these are the values: 0.4 log of 1 by 0.4 plus 0.13 log of 1 by 0.13 plus 0.04 log of 1 by 0.04 plus 0.15 log of 1 by 0.15 plus 0.28 log of 1 by 0.28. Okay, this is how we find, right? And then I'll show you for the first three entropies. I will show you how to type it in the calculator. Okay, so just for a quick method of finding the values. Okay, so this is how the equation. So what is the value of h of x? Let's find the value of h of x using calculator. So h of x is equal to, let me see, 0.4 log 1 by 0.4. So 0.4 log to the base 2, 0.4 inverse. Okay, this is the first term, right? This is how I write. See, this is the easiest method. Okay, plus second term is 0.13 log of 1 by 0.13. 0.13 log to the base 2, 0.13 inverse. Okay, see, remember the base of every log function is 2. Okay, it's not 10. So suppose if you don't have this, okay, if you don't have this button, if you don't have this function, then all you need to do is, as usual, find the value using the normal log, that is base 10 log from your calculator, and then whatever answer you are getting, divide that answer with log 2. That's all. Okay, so this is the second term plus, now what is the third term? 0.04, right? 0.04 log to the base 2, 0.04 inverse. Okay, next we have 0.15 plus 0.15 log to the base 2, 0.15 inverse. Okay, plus 0.28 log to the base 2, 0.28 inverse. Okay, and you will get, this is how we find. So you will get, let me see, you will get 2.022 bits per symbol. That's the answer of h of x. 2.022 bits per symbol. This is the value of h of x. Okay, now I'm going to find the value of h of y. So how will I find the value of h of y? Before finding the value of h of y, I need to find the value of p of y. Okay, because h of y can be only be written using the p of y equations, right? So how do I find the value of p of y? That also I have discussed in the previous videos, right? That is, all you need to do is simply add all the elements column wise, right? So this is the value. If you add all the elements of the first column, you will get p of y1. If you add all the elements of the second column, you will get p of y2. If you add all the elements of the third column, you will get p of y3. If you add all the elements of the fourth column, you will get p of y4. You see, so which means this matrix is actually having 5 rows and 4 columns. 5 rows and 4 columns. Look at this, m by n. You have learned about this, m by n, where m is the number of transmitted symbols and n is the number of received symbols. And this is a 5 by 4 matrix, which means from here so you can understand this as a 5 transmitted symbols and 4 received symbols. Okay, So now let me find the value of P of y1, P of y2, P of y3, P of y4. So what is the value of P of y1? 0.2 plus 0.1 plus 0 plus 0.04 plus 0, which is 0.34. 0.34, okay, comma. Next is, let me see, adding all this, 0.01 plus 0.02 plus 0.04 plus 0.06. 1 plus 2, 3, 3 plus 4, 7, 7 plus 6, 13. So it is 0.13. 0.13. Next is adding all the elements in the third column. This is 2. Here 1 plus 2, 3, 3 plus 1, 4, 4 plus 2, 6. It is 0.26. 0.26. Now adding all the elements of the fourth column, you will get 1 plus 6, 7, 0.27. You will get 0.27. See, this is how we find the value of P of y. So in that case, what is the equation for h of y? H of y, the equation of h of y is equal to sigma j is equal to 1 to n P of yj log of 1 by P of yj, right? Or in other words, this is nothing but, let me write from here. So this is nothing but, yes, 0.34 log of 1 by 0.34 plus 0.13 log of 1 by 0.13 plus 0.26 log of 1 by 0.26 plus 0.27 log of 1 by 0.27. Remember, the base is all 2, okay? So I'm going to type that in the calculator. Let's see what I get. So this is, first term is 0.34 log 1 by 0.0. So 0.34 log to the base 2, 0.34 inverse. Okay? 0.34 inverse plus, next is 0.13, right? So it is 0.13 log to the base 2, 0.13 inverse. Okay? Plus, next is 0.26. 0.26 log to the base 2, 0.26 inverse. Okay? Plus 0.27 log to the base 2, 0.27 inverse. Okay? This is how we find it. This is the this is 0.27's term. This is 0.26. This is 0.13. And this is 0.34, right? So you'll get 1.927. 1.927 bits per symbol. Therefore, h of y is equal to 1.927, right? 1.927 bits per symbol. This is the value of h of y, right? This is how we find the value of h of y. Okay, now we can find the value of h of xy, right? But to find the value of h of xy, p of xy is already given. P of xy is already given, right? So I can use this equation to find the value of h of xy. What is the equation for h of xy? H of x comma y is equal to sigma k is equal to 1 to m, sigma j is equal to 1 to n, p of xk comma yj log of 1 by p of xk comma yj. Okay, so this is the equation, which means what you need to do is, just like how I found the information of the average information of each and every values in this probability, like that I need to find the average information of each and every elements in this probability, right? Which means 0.2 log 1 by 0.2 plus this is 0, so you don't have to consider that, plus 0.2 log 1 by 0.2 plus this is also 0.1 log 1 by 0.1 plus these three terms, right? 0.01 log 1 by 0.01 plus 0.01 log 1 by 0.01 plus 0.01 log 1 by 0.01, like that we say for each and every elements, right? Up to last three terms will be 0.06 log 1 by 0.06 plus 0.02 log 1 by 0.02 plus 0.2 log 1 by 0.2, right? So this is how we find the values of each and every one of these elements, right? But writing all these elements will take a lot of time. So what I am going to do is that if you look very carefully, some of these elements are repeating, right? So you can multiply that by the number of times it is repeating, so it will save a lot of time. For example, 0.2 is repeating how many times? Let me see. 1, 2, 3. So 0.2 is repeating 3 times. So I can say that h of xy is equal to 3 into 0.2 log of 1 by 0.2. See, this is what I meant. So you can so you don't have to write the same term 3 times. So this is like that, you can save time. Okay, plus now next is what will I take? I'll take 0.1. Right, next term is 0.1. So 0.1, how many times is it repeating? 0.1 no, 0.1 is only one time, right? It's only repeating one time, so just write only once. 0.1 log 1 by 0.1. Okay, plus now next term I will take is 0.01. How many times 0.01 is repeating? 1, 2, 3, 4. It's repeating 4 times, right? It's repeating 4 times. So 4 into 0.01. So 4 into 0.01 log of 1 by 0.01 plus. Okay, now next is which value? 0.01 I have already considered. Next is 0.02. 0.02, let me see how many times. 1, 2, then nothing over here, 3. So it is 3 into 0.02, right? It is 3 into 0.02 log of 1 by 0.02. Okay, plus, right? Now 0.02 is also considered. The next is 0.04. all right, how many times 0.04 is repeating? 1, 2, that's it. So it's repeating only 2 times, so it is 2 into 0.04. So 2 into 0.04 log of 1 by 0.04 plus. Okay, so now that's also done. Now any other number? 0.01 I have already considered. 0.06, right? And that is repeating how many times? 2 times, right? So 2 into 0.06. 2 into 0.06 log of 1 by 0.06. Okay, now let me see if there's any other value. Right? No, this is I already considered. This also I have already considered. So I have written all the statements, right? So this is the equation, right? Or this can, or I can simplify this. Instead of writing this, I can write this as 0.6. 0.6 log of 1 by 0.2 plus 0.1 log of 1 by 0.1 plus this is 4 into 0.01 is 0.04 log of 1 by 0.04 plus this is 0.06 log of 1 by 0.02 plus this is 0.08, right? 0.08 log of 1 by 0.04 plus, and this is 0.12, right? So 0.12 log of 1 by 0.06. Okay, I'll find the entropy using calculator for this also, just to show you how to do it. Okay, so this also, how do we find it? This is 0.6. first term is 0.6 log 1 by 0.2, which is, I write 0.6 log to the base 2 0.2 inverse. Okay, this is the easiest method. Plus now 0.1 log 1 by 0.1, 0.1 log to the base 2 0.1 inverse. Okay, plus 0.04, 0.04 log to the base 2 0.04 inverse. Okay, plus 0.06, right? 0.06 log to the base 2 0.02 inverse. Okay, plus 0.08 log to the base 2 0.04 inverse. Okay, plus 0.12 log to the base 2 0.06. all right, and you will get inverse. I forgot to put it's inverse. Let me see if I have forgot inverse anywhere else, just to make sure. Okay, All right, it is 0.04 log of, this term is 0.01, right? Not 4, this is 0.01 over here. So which means over here, right, 0.04. Over here it is 0.04 log of 1 by 0.01 actually, right? That's the problem with online class. There's nobody to correct me. If this had been in actual class, then my students would have protected me from this. 0.1 log or 0.1 inverse, then we have 0.6 log of 0.2 inverse. All right, let's see. So you get 3.188. Let me see if the answer is correct. Yeah, the answer is correct. 3.188 bits per symbol, right? So this is 3.188 bits per symbol. This is the value of h of xy, right? So this is how we find the value of h of xy. Now I'm going to find the value of h of x by y. So now you know how to type in the calculator, right? So now in the coming entropies, you have to learn to type those values in the calculator by yourself and learn how to find the values, okay? Because everyone has their own style of finding. This is just my way of writing. If you have any other way of writing, you can apply that also. There's no problem, okay? So next I'm going to find the value of, let me see, I'll find the value of this, h of x by y. But to find the value of h of x by y, I need to find the value of p of x by y. I need to find the value of p of x by y. Alright, so how will I find the value of p of x by y? How will I find the value of p of x by y? That is something which you all need to understand. P of x by y is equal to, right? So how will I find there? Okay, so how will I find the value of p of x by y? You see, this is p of x by y. You already know that p of x by y is equal to p of x y by p of y. We have discussed this in the previous videos, right? So you're going to understand. So I'm going to tell you the procedure of how to find the p of x by y, but the reason behind this procedure you need to understand by yourself, looking at the previous videos, okay? So p of x by y is equal to p of xy by p of y, which is, so divide by p of y, right? So I already have p of xy. Where's my p of xy? This is my p of xy. I already have p of xy. Divide by p of y. I already have p of y also. So that means I have p of xy and I have p of y. So how will I find p of x by y? Just take its divisor, right? Just divide these two matrices, right? Divide these two matrices. And how do I divide these two matrices? By dividing it by each of its terms column wise, with the corresponding column wise, which is, that means p of x by y is equal to, the first term will be here 0.34, here is 0.2. So therefore the first term is 0.2 by 0.34. That is the first term. Okay, likewise, next is 0.1 by 0.34. 0.1 by 0.34. The next term is 0. 0 by 0.34 is 0 itself, right? You don't have to write it. 0.04 by 0.34. 0.04 by 0.34. And the last one is 0. Okay, 0. See, this is how you write it, right? What is the second term? 0.13. So the second column, you're going to divide each of these terms with 0.13. So it will be, first term is 0. Second one is 0.01. So it is 0.01 by 0.13. Next is 0.02. 0.02 by 0.13. Next is 0.04 by 0.13. 0.13. Next is 0.06 by 0.13. 0.06 by 0.13. Okay, this is how we find the value. Second one, you won't have space to write the remaining, I believe, right? Oh my goodness. Let's write it again in that case. I need more space. P of x by y, okay, is equal to, let me write this again. And I need to write it more smaller also. 0.2 by 0.34, 0.1 by 0.34, 0, 0.04 by 0.34, 0, next is 0, 0.01 by 0.13, 0.02 by 0.13, and we have 0.04 by 0.13, then we have 0.06 by 0.13. That's the second one. The third one is 0.26. So divide each of these elements with 0.26. So it will be 0.2 by 0.26, 0.01 by 0.26, 0.02 by 0.26, 0.01 by 0.26, 0.02 by 0.26, right? And the last column you got to divide with 0.27. So it is 0, then 0.01 by 0.27, then it will be, here it is 0, here it is 0.06 by 0.27, then last one is 0.2 by 0.27. This is the value of P of x by y, right? This is the value of P of x by y. So now I'm going to find the value of h of x by y. And do not ever make the mistake of the equation. Look at the equation very carefully. What is the equation for h of x by y? The equation h of y is not like your ordinary equation what you have so far, how you found the entropy. This entropy, to find this entropy is little bit different, right? How do you find the entropy of this? Look at the equation and you'll understand. This is sigma k is equal to 1 to m, sigma j is equal to 1 to n, p of xk comma yj, not p of xk by yj, it is p of xk comma yj, log 1 by p of xk by yj. See? So this is not a conditional probability. What is this? This is nothing but the values of your joint probability matrix. This is nothing but the values of your joint probability matrix, right? That is what this means. And this is this conditional probability are these elements. That is what this means. Okay. In other words, to find the value, let me write it. The first term, all right. The first term is 0.2. See, p of x1 y1. It is 0.2. So 0.2 log of, okay, now 1 by p of xk by yj, 1 by p of xk by yj. What is p of xk by yj? This is my p of xk by yj, and 1 by of it means reciprocal of this, so which means it is 0.34 by 0.2. This is how we write it. Okay, you take to find the answer for this, to find the value of this, you take the values from both the matrix. This is from, you take this from the joint probability matrix p of xy, and this you will take it from the conditional matrix, that is p of x by y. That's how you find this. Okay, plus now what's in second, now what's the next term? Next term is this one, right, which is 0.2. so which means it is 0.2 log of 1 by this, which is 0.26 by 0.2. Okay, plus, right? Now you know how to do this, right? Now the next element is 0.1, I believe, right? 0.1. So it is 0.1 log of reciprocal of this, which is 0.34 by 0.1 plus, and this one will be 0.01. So it is 0.01 log of 0.13 by 0.01. Okay, plus the next element is also 0.01. So it is 0.01 log of 0.01 log of 0.26 by 0.01, okay, plus next is this one, right, that is 0.01. So which means 0.01 log of 0.27 by 0.01, okay, plus this is 0, this is 0.02, right, so 0.02 log of 0.02 log of 0.13 by 0.02 plus this also 0.02, so 0.02 log of 0.26 by 0.02, okay, plus, so this found this is 0. Now you're going to find this, which is element 0.04, so that means 0.04, right, this is 0.04 log of, and the reciprocal of this, right, 1 by this, so reciprocal of this, which is 0.34 by 0.04 plus, and the other one is 0.04, so 0.04 log of reciprocal of this 0.13 by 0.04 plus, now next is this one, right, it is 0.01, so which means 0.01 log of 0.26 by 0.01, okay, plus next element is 0. What I have written is 0.01, right, next is 0.06, so which means 0.06 log of 0.27 by 0.06 plus this is 0, and next you have is 0.06, I believe, right, 0.06, so 0.06 log of 0.13 by 0.06 plus next is you have is 0.02 log of 0.26 by 0.02 plus, and the last term is 0.02, so therefore it is 0.2 log of 0.27 by 0.2, okay. I just want you all to understand how to write each of these logarithmic function, that is why, okay. Then just to give you one more heads up, some of these terms, just like in this case, alright, just like in this joint probability matrix, here you can see that some of the terms are repeating. That's why I multiplied with that number of times, right, just to save time. Like that, here I didn't apply that because I just want you all, this is the first time we are writing this, so I don't want you all to confuse yourself. That's why I didn't write like that, okay. So here also, if any of these terms are repeating, then you can multiply that by 2. For example, this two terms, see, 0.01 by 0.26 and 0.01 by 0.26, both of them, for these two elements, both of them values are also same, right, 0.01 and 0.01. So these two are repeating 2 times, understood, these two are repeating, so you just have to write 2 into, right, I have written twice, I have written those terms twice, right, one is over here and the other is over here, okay. So if instead of writing these two terms separately, it becomes 2 into 0.01, so that will save more time, right, like that. If you see any of these terms are repeating, you can write like that, so that will save more and more time for you, okay. So this is the first time you're writing only, I just wanted to know how to write all this, that's why, okay. So now if you put this all in a calculator and type it, you will get the answer as, let me check, you will get h of x by y as 1.261, you will get 1.261 bits per symbol, okay, you will get bits per symbol. All right, I want you all to type this in the calculator, okay, so that you will understand how to do this. All right, all of you have your own type of calculator, and depending on that type, depending on the functions it has, I want you all to be familiarized. That is what is the most important about this problem. Learn how to type all this in a calculator very fast, okay. So next, and now I found h of x by y. Now I'm going to find the value of h of y by x, right. So now I'm going to find the value of h of y by x. So how do I find the value of h of y by x? To find the value of h of y by x, I need to first find the value of p of y by x. P of y by x. I need to find the value of P of y by x. So now how will I find the value of P of y by x? How will I find the value of P of y by x? That is, we all know that also same thing. We all know that P of xy, or sorry, P of y by x. P of y by x is equal to P of xy by P of x. P of xy by P of x. P of y by x is equal to P of xy by P of x, right? This is a conditional probability, right? It's just like the other one. So here we need, this is nothing but the joint probability matrix by P of x, transmitter matrix. That is, we already have the value of P of xy over here, okay? That is P of xy by P of x. And what is P of x? And what is my P of x? This is my P of x, right? This is my P of x. So how do I divide this with this, right? This, in that case, it should be row wise. Okay, I'm going to divide each and every element row wise with this corresponding element from this matrix. That means P of the first term of P of y by x, alright, the first term will be 0.2. So it will be 0.2 and 0.4. So it is 0.2 by 0.4. And row wise, the denominator will be the same. 0.2 by 0.4. Okay, next term is 0. Alright, next term is 0. Then you have also, this is also 0.2 by 0.2 by 0.4. Then we have 0. Okay, so that is the first row. Now the second row, you should divide it with 0.13. So it becomes 0.1 by 0.13, 0.1 by 0.13. Okay, then it will be, here it is 0.01 by 0.13, and that's repeated 3 times, right? So I can say 0.01 by 0.13, 0.01 by 0.13, 0.01 by 0.13. All right, now the third row, it is dividing by 0.04. So this is already 0. Okay, this is 0.02 by 0.04. It's repeating 2 times. 0.02 by 0.04. Again 0.02 by 0.04. Okay, next, and this is also 0. This is 0. Okay, now third row is dividing with 0.15. So it is 0.04 by 0.15. Okay, again 0.04 by 0.15. Okay, then we have 0.01 by 0.15, 0.01 by 0.15. Then we have 0.06 by 0.15, 0.06 by 0.15, right? And for the last row, it is dividing each of this with 0.28. So this is 0, this is 0.06 by 0.28, 0.06 by 0.28, 0.02 by 0.28, then we have 0.2 by 0.28. This is P of y by x, alright? And also the equation of h of y by x should be used with caution. That is, h of y by x is also equal to sigma k is equal to 1 to m, sigma j is equal to 1 to n. Again, this is P of xk comma yj. There is no other equation, right? Again, it is P of xk comma yj, which means you need these elements also, right, to substitute in this equation. Log of 1 by P of yj by xk, which are the elements from this matrix. Okay, so this represents the elements from this matrix, and this represents the elements from this matrix. Okay, so I'm going to substitute it. So here, let me see if there's any repeating, so I can save time. Yes, these two are, I believe it's repeating, right? 0.2 and 0. These two are repeating twice, right? Let me see if their values are also repeating. 0.2. So which means I can say this is 2 into 0.2 log of, and reciprocal of this, right? 1 by P of yj by xi means reciprocal of this, which is 0.4 by 0.2, right? That's the element. plus, now for the second row, it is 0.1. Let me see, 0.1. Is there any other 0.1? No. So it is 0.1. Okay, that is, this element is 0.1, and this element is from here, a reciprocal of this. So log of 0.13 by 0.1. Okay, plus, and these three elements are repeating 3 times, right? These 3 elements are repeating 3 times. That saves more time. So it will be 3 into, let me see, 0.01, right? It's repeating 3 times. So 0.01 log of opposite of the reciprocal of this, 0.13 by 0.01. Okay, plus, so the second row is over, and for the third row, these two elements are repeating twice, right? 0.02 and 0.02. So it is 2 into 0.02 log of, and here you will get 0.04 by 0.02. Okay, plus, all right. Now if I'm going for the fourth row, and for the fourth row, thank goodness, these two are repeating twice, right? These two are repeating twice. So you will have 2 into 0.04 log of 0.15 by 0.04. Okay, plus, right, these two are repeating twice, these are repeating only one time, right? So it is 0.01 and 0.06. 0.01 log of 0.15 by 0.01. Okay, plus 0.06 log of 0.15 by 0.06. Okay, plus, and for the fourth row, the final row, 0.06 log of 0.28 by 0.06. Okay, plus 0.02, right? 0.02. So 0.02 log of 0.28 by 0.02, right? Plus, and the last one, oh, this is this is 0.0 to 0.2, so it's different, right? 0.2. So this is 0.2 log of reciprocal of this, 0.28 by 0.2. This is how you find the value of h of y by x. Okay, and so if you type all this in the calculator, you will get the answer as, let me see, h of y by x, right? Let me see, you will get the answer as h of y by x is equal to 1.166 bits per symbol. So now you found the value of h of y by x, 1.166 bits per symbol. Now I'm going to find the value of I of xy, and that is very easy. I of xy is nothing but, you can use any one of those 3 basic equations, right? What are the different equations? First equation is h of x minus h of x by y, or you can use h of x plus h of y plus h of xy, or you can use h of y minus h of y by x. You can use any equation. I'm going to use this equation. Whichever equation you're using, you will get the same answer. So I'm going to use this equation, h of x minus h of x by y. So let me see, what is the value of h of x? What value did I get for h of x? H of x is equal to, is h of x, yes, 2.022 bits per symbol. So it is 2.022 minus, and h of x by y, what did I get for h of x by y? 1.261 bits per symbol. 1.261 bits per symbol. Let me see. 2.022 minus 1.261, right? 2.022 minus 1.261, and you will get 0.761. This is equal to 0.761 bits per symbol. Bits per symbol. The unit of mutual information is also bits per symbol. Okay, so I found. Now I'm going to verify my relationships, right? Verify my relationship. What is the first relationship that you have studied? That is h of xy is equal to h of x plus h of y by x. Let me see, what is the equation for h of xy? What value did you get for h of xy? h of xy is equal to 3.188, right? So here it should be 3.188 is equal to, and what is h of x? Let me see, h of x you got us 2.022. So 2.022 plus, and what is h of y by x? H of y by x. Where's h of y by x? H of y by x is 1.166, right? So 1.166. See if you get the same answer. If you're not, then there's something wrong with the answer. Plus 1.166, 1.166. You will get 3.188. Yes, so this is correct. Therefore, LHS is equal to RHS. LHS is equal to RHS. Okay, see, even if they have not asked you to find the relationships, even if they haven't asked you to verify the relationship, you can still use this equation to check if your answer is correct or not. That is a trick behind this. Okay, that's one of the tricks of using these equations. You can just check if your answer is correct or not, because this relationship will always be satisfied. Second relationship is h of xy is equal to h of y plus h of x by y, right? And what is h of xy? 3.188. So which means 3.188 is equal to, what is the value of h of y? What is the value of h of y? H of xy is 1.261. And what is the value of h of y? H of y, let me see, h of y, yes, 1.927. 1.927. Let me see if I get the same answer. 1.927 plus 1.261, and you should supposed to get 3.188. Yes, 3.188. So this is also correct. Therefore, here also LHS is equal to RHS, right? And next, the relationship you have studied is h of x must be greater than or equal to h of x by y. Okay, let me see, what is the value of h of x? You got is 2.022, right? So 2.022 is greater than 2.022 is greater than h of x by y is 1.261. 1.261. It's greater, right? So therefore this relationship is also verified, right? That is LHS is greater than RHS, right? So, and the last one is h of y should be greater than or equal to h of y by x. What is the value of h of y? H of y is 1.927. 1.927, and it is, and let me, what's h of y by x? H of y by is 1.166. 1.166. This is also greater. Therefore, LHS is greater than RHS, right? Therefore, all relationships are verified. Okay, this is how we do the problem. Okay, so this takes time. That is what is most important. This takes time. Usually this question will be asked for, maybe for it has been asked for 10 marks, it has been asked for 12 marks, it has even been asked for 15 marks, because this is a time consuming problem, right? So the speed comes from by how you are typing all these values inside your calculator. That should be taken as a practice. So I want all of you to not simply write the answer. I want all of you to literally type these values in the calculator and see if you're getting the answer. Okay, that is where your practice actually lies. That is the most important thing. Okay, if this had been an offline class, if you are having an actual classroom, I would have made you all do this. I would have made you all taught you how to type all this into the calculator. So now I need you all to figure out by yourself, okay, how to type all this in the calculator and then get the answer, okay? And speed is very important. Do not spend too much time on this. Even though this is a lengthy problem, you should not spend too much time on this, okay?